All right, I guess we can kick it off. So first of all, welcome to everybody who is joining today. My name is Johannes. I will be hosting the sessions. I'm part of the startup Autobahn team, and I'm really happy to welcome Georges and Paul with me on stage. Georges is a part of ZF, and Paul is part of the startup called PreAct. And they will be talking about the project, and they worked on near-field sensing and how near-field sensing can help also in different ADAS functions. So I guess Paul and George, the stage is yours.
All right.
Thank you, Johannes.
Good morning. Well, it's morning here in Hawaii. So anyway, good morning, good afternoon, wherever you are. Today, ZF and PreAct will talk about near-field sensing for use in imminent collision detection, ADAS, and other convenience and safety features for automotive. My name is Paul Dreisch. I'm the co-founder and CEO of PreAct Technologies, and with me is George Halsdorf, and I'll let him introduce himself.
Yeah, just a few words, and I will hand over back to you, Paul. So, George Halsdorf, my name. I'm located in corporate R&D within the ZF group, and we are doing advanced system development for everything about road safety. So basically avoiding accidents, mitigating accidents, helping after accidents. So this is more or less our focus where we are heading for. And in this context, we met Paul and his team, and looking forward to presenting our topic today. Thanks.
All right. Thanks, George. So why is imminent collision detection important? You know, won't self-driving cars and all these new safety features prevent all these accidents and injuries and deaths? Well, according to the IIHS, you know, the clear answer is no. They actually believe that 2/3 of all car crashes are due to what they call normal driving behavior, basically legal driving. So additionally, each year, the number of crashes, injuries, and deaths on a global basis continues to climb. And it's massive numbers, like almost 1.5 million people die every year from car crashes, and 50 million are injured. And, you know, today's safety technology can't quite seem to close that gap. Great stuff happening in active safety, and passive. Passive is still, you know, it's been operating, you know, airbags and seat belts in a solid and consistent manner for decades. But still, what we're trying to do is to bridge that gap, and how to bring these two systems together to help mitigate injuries and deaths from collisions. Hang on one second. So what can be done? Obviously, you know, you can deploy pre-crash airbags and, you know, engage seat belts prior to impact. You can deploy an external airbag like ZF makes to reduce the impact from the collision. Today's newer electronic suspensions can tilt for, you know, kind of so the frame can take more impact, or other ways in which it can kind of mitigate the impact. You know, there's pre-crash seats and larger airbags, all kinds of things that can be done. And again, according to NHTSA, you know, if you can do just even some of these things, you can greatly reduce the number of injuries and deaths from car crashes today. So what is our project? PreAct and ZF have been working together for the last 2 years on an imminent collision detection system, and that ZF brings, you know, tremendous experience in predictive safety and ADAS and passive safety. And what we've been working on for these couple of years is the idea to bring a first of its kind pre-crash system to market, and at a low enough cost that it could be deployed on all vehicles, not just high-end vehicles. We're also working on a suite of countermeasures to collisions, kind of some of the things that we I just talked about on the last slide. Plus, we're also working on other comfort and convenience features that can be enabled using the sensing platform that we're working on. And after 2 years, I can confidently say that we feel very comfortable with the accuracy of the imminent collision predictions that the system outputs. So we talked a little bit about what ZF brings to the table. What is PreAct bringing to the table? PreAct has developed the automotive industry's first external continuous wave time-of-flight camera. And it's a dual mode camera that includes the near IR spectrum as well as typical RGB camera. And what this does is, so in addition to the RGB image, it provides a LiDAR-like point cloud and depth map. And it also operates at up to 500 frames per second, which is obviously critically important for imminent collision detection and tracking of fast-moving near-in objects. And also, the cameras have lightning fast edge processing. So all of the perception layer and object threat assessment and that happens on the edge. So it is super fast. Here's an example of just some of the crash testing we've done together. So the first image was the actual video output. The second one is more the raw camera feed and that. So that was basically the same thing same image, just two different ways of looking at it. And again, what this live testing has shown is that, for one example, frontal pre-crash happening at like 50 miles per hour, we're able to detect an imminent collision with reliability up to 230 milliseconds pre-crash. We've also tested many other much harder scenarios, such as just like a 20-25% overlap, and still can reliably predict an imminent collision. So what can you do, when you've developed a camera and a system that can look out, and work like LiDAR, but much, much, much faster and kind of orders of magnitude cheaper? Well, you can enable a number of new use cases that were previously impossible with like radar and ultrasonic sensors. And you can also enhance some use cases that currently use those kind of near field sensors. So anything from blind spot monitoring to self-parking to pedal misapplication detection, rear automatic emergency braking, external airbags, pedestrian detection. And another really cool thing that we're working on with ZF that I'll talk about in a second is the automatic door opener and clearance detection. So this is something we're working on with ZF, a different group from George, but and it's called automatic door actuation. And the idea is you install one of these cameras on each side of the car, and you're able to have the door automatically open. And while that may sound simple, you do not want your door to run into a curb, a pole, a bicyclist that's coming by, a car. So it almost has to work like a pre-crash system that also has that, LiDAR-like ability to detect very small objects. So you need that kind of centimeter level accuracy and operate in all environmental conditions. So let me I have a little video here. This is actual output from us testing a door with our camera on it. And it's looking at the little pole on the right. That's actually not even a pole. That is a kind of steel post that's only a few centimeters in diameter. So a quite small object. And we're able to reliably, determine, that it's there and not hit a curb, not, a bush, anything like that. So in conclusion, the whole idea here is by utilizing PreAct's kind of dual mode camera, we can replace a bunch of the other near field sensors that are on cars today, and then produce a lower bill of material cost for the OEM, while also providing much higher performance of those sensing systems. And so again, together we're working on the enhancement and enablement of pre-crash systems, automatic door actuation, and many of the other new and existing applications that we talked about. So thank you very much. I think we're opening it up to questions now.
Thanks, Paul.
Great, thanks, Paul. Yeah, to the audience, please feel free to post all your questions in the chat or in the Q&A section. Or if you want to have your question live here on stage, you can also request to join the stage by hitting the red button on the top right corner. So whatever way is fine with us. We're just waiting for your questions. Maybe while we're waiting for the questions, Georges, maybe you could also elaborate a little bit from ZF side why this topic for you as a company or as a group has such as importance, and what steps you're taking, and maybe talking about the collaboration with PreAct.
Yeah, basically a bit about the history. So basically we have been working on pre-crash systems for more than 5 years now, I would say. And we know how fast and how accurate a sensor has to be, and that ADAS sensors today are not delivering that quality because they have different use cases and the technology is not focusing on those aspects. So and basically this is why we were looking for technology which is enabling this, and via this we met with Paul and his team, and it sounds very promising, and we hooked on it, and now we are looking forward to it. But also to mention what we also quite aware of is that just bringing into a sensor for safety cases is pretty difficult in automotive. So this is why also we use the ZF network to identify further use cases to get convenience use cases, enabling those like the door opener of Johannes. And this is overall a pretty interesting topic for us in this case, because I think it matches pretty well to our ZF portfolio overall, and it's helping us to enhance also the near-field sensing. Yeah. So this is why it is pretty interesting for us.
Great, and I guess just adding on to this, there's a question popped up, and I think that goes to Paul. So could you talk a little bit about the range of your sensors and maybe some key figures of the sensors you developed?
Sure. Well, we're always working on enhancing the product and that, but today's sensor works up to about 25 meters with kind of consistent accuracy and detection capabilities. So kind of that 0 to 25 meters. And it does work from almost 0, It works from, centimeters away from the camera all the way out to 25 meters. So.
Great, thank you. So maybe we'll give it one more minute. Typing maybe takes a while, so people.
No.
Maybe another question. So you touched on different use cases you are taking into consideration for the future. what do you think are the most promising ones in regards to value for customer and also for safety issues? And maybe from the ZF side, but also from Paul, your perspective on that.
Sure.
Paul, do you want to start?
I thought you were going to start. I mean, I can't. I mean, it's it kind of depends. You know, obviously things like the automatic door actuation we see as a huge market, and that almost every OEM that we've spoken to has tried to make that work for years and struggled. So we think that's going to be a huge market. And you know, and as George said, you know, it's tough to deploy new functional safety systems kind of standalone by themselves. So anything that can get the kind of technology onto the vehicle just will make that happen faster and easier. So we're getting, there's a lot of interest around, curb detection, so you don't scrape your wheels when you're parallel parking, clearance detection, other things. There's not much volume in it today, but we're working with a number of the kind of self-driving car and truck technology providers, again, for the close-in near-field sensing. There's just a ton of use cases that seem to get traction on their own that, again, are not safety oriented. So, you have anything to add there, George?
Basically all said. No, yeah. So it's important about to get the convenience, but for us it's the safety. Yeah. Let's say most of the others don't need that high update rate, so basically they could do it with different technologies, I guess, at some point. But still, with the direct measuring of the 3D time of flight, it's still a very, very interesting topic also for parking, automated valid parking, gesture detection, pedestrian detection. So this is also something where we see still gaps in industry and could think of to improve that gap. So this is also, up to our opinion, a very important topic where we're looking at. It's about automation, it's about convenience, it's about safety.
Mm-hmm.
Great. And now maybe from going to opportunities, maybe also to challenges. So Josh, I would like to know what kind of limitations did you discover in the POC, and to avoid any silence, I would say, George, maybe you go first, and then Paul, you can.
Any limitations? No, of course not. Yes, of course there are. Yeah, so basically also time of flight has its physical limitations and challenges. Yeah, so we have found some topics where we are pretty keen on that we will find a solution. But also, let's say for the safety case itself, it's still to be clarified. Maybe you need other plausibilization paths like a radar at some point to really plausibilize it with the different physical effect. Yeah. So basically, this is not a limitation in that way, but you have to take care of it from a robustness point of view, that you combine the right technologies with the right capabilities, and you understand exactly how much you can rely on what information. And this is what we are still working on, to really get a very good feeling for that. Yeah, but it's at the moment it's pretty much promising. Yeah.
Mm-hmm. Yeah.
I mean, from the parking proof of concept, maybe you can say a bit more. Yeah, that's a topic I'm not that familiar with.
Yeah, I think George covered it pretty well. Part of time of flight is not a new technology, and what kind of makes PreAct unique is what we've been able to do with existing technology to really make it work in a much better way, and in those difficult environmental conditions where time of flight normally would struggle. And again, we continue to enhance that, and it's, it gets better every week. But so far, especially in certain use cases, it's just obviously a much higher performance solution than kind of what OEMs might use today. And that, and in others, we're, it's a work in progress, in that, but it's going really, really well so far. And, we enjoy every time a customer says they're going to, use our sensors or technology in place of, their existing ultrasonic sensors or near radar or things like that. It certainly gets us excited. So it kind of proves the point.
Okay. And then a question directed more to the ZF side is how confident are you that this technology will be rolled out? And do you guys already have a timeline in mind? I know we're talking today about a POC, but maybe company strategy-wise, do you guys have something in your pocket or some timeline you would like to share with us today?
How confident are we? So basically what we can say, it's in our opinion, it's the best bet which we found until now. Yeah, so we are pretty confident that we can solve it, and especially in combination maybe with existing technologies, we are pretty confident. Yeah, can't give a number, but from our opinion, we have been looking a lot around technologies, and this is definitely exactly, especially with the expertise of PreAct, it's the best solution we found until now for the safety use cases. Target timeline, let's say, for the safety cases, it will not be the first application to be implemented via PreAct. Yeah, that's clear, I guess, because it's the most challenging, and we cannot accept any false positives. So basically, a very, 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 very low amount of false positives. So basically, this is why safety is definitely not the very first use case. We would say in 2026, 2027, we see customers who are looking for topics where it might match perfectly. Yeah, so this is more or less the timeline I would see for the safety aspects. Yeah.
Mm-hmm. Yeah. We're looking years ahead of, years sooner though for non-functional safety applications though, and kind of unrelated to ZF, will kind of our first commercial product will be late next year. But that's again not a functional safety product, and different program.
And then maybe, so in order to keep that timeline, George, it's 2027. The word is out. What are the next steps after completing this POC? What are the next milestones you maybe already defined? Maybe could you give us a little bit of insights on how this development is going on in ZF?
Yep. Up to now, we had lots of tests done by PreAct and simulations, which we have done also to evaluate our scenario-based approach to really see what could be the effectiveness on road safety, and that's done mostly by simulations. And of course, but at the beginning, we had pretty much basic simulations based on data sheets. And right now, we are looking for more highly sophisticated sensor models and simulation. That's one topic where we are working on. And the other one is really also putting it into a car and doing physical tests with our own algorithms, with our own car at our test tracks. So that's more or less planned for end of this year, beginning of next year. And after that, I think we will get a better and better picture. Yeah. Also, PreAct will launch its TrueSense 3.0, so we will also get a feeling for the next generation of sensing technology which they are launching, and then get a better and better feeling for it. Yeah. So I think from a timeline point of view, this is matching pretty well with 2027 to really say we finish our advanced analysis by end of 2022, I would guess. Yeah, and then hopefully the next steps.
Mm-hmm. Yep.
Great. And maybe a last of question. So Paul, obviously, Preact still being a relative working with different companies. So maybe for you, what is Preact? What kind of customers would you like to approach? What are the customers you're looking for? Maybe someone in the audience is already thinking about getting in touch with you. So what are you looking for? What are your capabilities? And maybe how can people also contact you after this breakout session?
Sure. So Preact is, we're not looking to ever become a tier 1. We're definitely a tier 2 supplier. Would be providing our either our technology or the cameras to tier 1 supplier. Some cases the OEM directly. We do have some contracts like that. And that again, I talked about the self-driving companies, and then also in the heavy trucking space as well. We have a number of areas where we're working on projects there. And we didn't talk about it here, and might not be the place, but we also work in the kind of usage-based insurance space, and we're working with a couple of the largest insurers in the world on a really unique way of doing driver behavior rating using our cameras and software. So.
Great. I think if there are no more questions from the audience at this point, big thank you to the both of you for presenting your POC, what you've been working on. Also a huge thank you to the audience for joining in. I guess Georges and Paul will be around in Hopin for a little bit. So if you would like to contact them and maybe in a more private video setting call, feel free to reach out to them. Martin Hoverkamp already has the question how to contact Preact. I would say find Paul within Hopin and send him a private message, or maybe Paul, you would like to share the email directly with Martin Hoverkamp after the session. And yes, I think it's a wrap. And enjoy your evening, Georges, and Paul. Enjoy your day.
Thank you very much, Johannes. Yeah.
Thank you.